I am increasingly of the mind that if you can't change your software, then the software is low quality. That is the practical, pragmatic realization of quality in your software. I don't care about anything else. I don't care what language it's in. I don't care what, if I can change it easily and safely, then it's good quality.
Yeah.
And pretty much, and there were some of these sort of deep tools that, things like modularity, cohesion, separation of concerns, encapsulation, abstraction, those sorts of coupling, those sorts of tools that allow us the freedom to make those kinds of moves when we realize, oh shit, we got it wrong.
Yeah, the freedom
to make the change.
And I think that's really important, because I think for me, one of those insights, or an emerging wave of insights over the years, has come from this idea. Okay, we're always operating with incomplete knowledge, so that means that whatever I'm building is in some sense wrong. Although I think wrong is sometimes there's too much attached to that word.
Your best guess so far.
It's my best, based on what I knew. It's we did our best job. This is what we've got, but now we've learned something from it, either because the world told us or because we learned as a result, our own awareness of this. But what's interesting is you can derive a lot of the ideas that we value, modularity, loose coupling, and all the rest of it, from an understanding of like, well, how would you build something if you didn't know everything?
Yes.
Here's the thing I'm not sure about. Here's the thing I'm very sure about. This thing I'm not sure about, I'm going to really ram it in there and couple tightly to it. No, you want to loosely couple to it, because this is probably going to change. Yeah, exactly. I'm going to isolate myself from that. It's just I'm not totally sure about it. I've kind of got an idea, but I want to put a little bit of distance between this, and that distance is our dependencies. That distance is our interfaces. That distance is, the idea is that all of this falls out naturally when you start saying, well, you can actually, and this is, I think, is fascinating, because it runs along a kind of an alternative axis. Sometimes they arrive at the same conclusion, but sometimes they don't, to the traditional language of abstraction and things like that. How would you modularize? Modularize according to abstraction. Well, there's multiple ways of abstraction. We have different paradigms for that. But what is interesting is going, well, how sure are you about this? And it's just like, well, I'm not, I'm pretty sure we've done something almost identical. It's not identical, but it's almost identical. Well, that gives us maybe high confidence, and this worked out well. That's the second bit. People normally forget that. Doing it, sometimes we get stuck in a rut. It's just like, we did this before, and how did that work out for you? Yeah, not very well, but we're going to do it again this way. It's just like, no. There's an opportunity here. And that's that idea of, it's good to have a few ideas that you can trade off against one another.
Yes.
But then you've got that other idea of like saying, well, let's go through this in terms of certainty. And I've done this a couple of times with people, and they're always kind of slightly freaked out, because you kind of come up with a rough kind of like sketch of what you're going to do, and say, well, hang on, but we haven't actually talked about all of the design detail that they normally talk about. It's just like, well, what we did is we've just drawn a bunch of boxes and lines and things based on your confidence. In other words, when I've asked a question and you've said, oh, yeah, we're not really sure how we're going to do that. Right, I've drawn a line. There's a boundary there of knowledge, because we're sure about one side, but we're not sure about the other. I don't care what it is. I don't care what paradigm we're talking. There's clearly something we're not sure about. So maybe we shouldn't hug it too closely. A little bit of looseness. A little bit of a wall would be good. Yeah. And likewise, when somebody says, oh, yeah, we're going to do it this way, and a colleague says, oh, I thought we were going to do it this way. You know what? There's a line there as well, because there's clearly, this is not settled. And it may turn out that one of them is right one year and the other one is right the next year. In other words, things may change, whether it's performance characteristics or whatever, that favor one and then the other. And again, that's the timeful rather than timeless quality. But that idea there that we can get a heads up just by actually almost constructively using our uncertainty as a positive aspect to sort of see, well, how does this work? And then we've got the empirical side of things, which is, okay, here's what kept changing every release. What were the hot spots? What did we keep going back and saying, oh no, this time it'll be right. We'll just add this here. And that kind of, I think one of the first times I ever really noticed that question of stability properly feeding back was a Java system. It was a company that was doing a Java system, and they had the debate about, they were having the debate and had not yet resolved it, about checked exceptions. And and for those tuning in who are not aware of this feature in Java, checked exceptions basically allow you to make exceptions part of the signature of a method, a sort of checkable aspect of the signature. And it's one of those things that in theory is a good idea, but that actually turns out that in practice, if you don't know exactly what you're doing, in other words, if you don't have perfect knowledge, and you're building a large system, they have a really nasty impact because they introduce an element that is unstable, or rather needs to be stable, but is not yet stable. In other words, how does this fail? I don't know yet because we haven't fully understood this. It goes right back to where we started. What are the failure modes of this?
Yeah.
Short of saying something trivial like there is an error, and that's often what these checked exceptions tend towards, which is throws framework error. In other words, actually that's of almost no use to anybody whatsoever. Bad things may happen. Well, we knew that because because bad things may happen. You end up either saying nothing at all, or you say it so precisely that unless you've actually had this out in the field for a long time and converged on that, the chances are somebody's going to come up with a new failure mode. Yes. And it's just like, oh, well, so the curious thing is what you've done is that your happy day scenario, what you want from the method, why the reason you called it, you don't call it, I'm not calling this method, except perhaps in a test, I'm not calling this method in order for it to fail. That's not my goal here. I'm calling this because I wanted a result. I'm expecting that it's all going to work out. Yeah. So therefore, right at the edge of my vision and edge of my awareness is all of these failures, all of these possible failures, which we've not yet explored. And as time goes by, we get more refined understanding. Oh, this could be distributed. Oh, well, our distributed bit throws different exceptions to the ones that are those. So we've now made this thing, which was local. Now it's okay. So we're going to have to change the signature again. So we've suddenly made something. We've caused churn in the interface. And this is one of those interesting things that comes out of the kind of the more empirical side of things. It's not that nobody who put that feature in Java did so maliciously or without thought. I certainly, my understanding at the time and everything leading up was like, no, there's some good thinking, solid thinking that goes right back to the 1970s in exploring all of this. But it's the scale. What happens when you actually create open systems that are large and with all manner of developers? It suddenly turns out, there's a fundamental problem here, and it's to do with rate of change and stability of knowledge, what we do and don't know. And that was a revelation. Anyway, for this team, it was a real revelation because they were split down the middle. Half were pro, half were anti, and I was just I can't come in and just sort of say, it's going to go this way or that way. So I actually came up with an empirical approach, and I basically said, don't make anything checked. Look at, before you decide to make something checked, as it were, and seal it in, look at how it's behaved over the last few iterations.
Write a test to simulate the failures as well.
Not just, but the failures, do all of those. And they were actually quite good at that. But your understanding of the failures is the real
how you respond to it. Absolutely.
Yeah. And it turns out that some of these kept changing on a frequent basis. And I said, look, that idea is not yet stabilized. That idea is still young. Don't nail it in place. And which was a polite way of saying, like, actually, probably, so in other words, don't make it checked until you're sure, which is a fancy way of saying don't make it checked, because the chances are they weren't going to go back and review stuff. But what we had is at least a maturity model. And it's this idea of that it doesn't matter what you think today, you're going to overvalue your confidence. And so it's this idea that time will give you the answer. I can't tell you how this is going to evolve. I can't tell you how other, and this goes across APIs. It's not just about failure modes. How this is going to evolve. How's it going to be used? What are the things that are frequently going to change? And then going back to your point about what we want to do is align the structures of our software with what are the frequent changes we actually experience, as opposed to, people often pad their design or add complexity because they're saying, oh, well, maybe this will change. It turns out that the better your imagination, the worse this gets. So if you are a creative and imaginative developer, you can imagine all kinds of possibilities and the gold plating and the extra hooks and bits and pieces. And so the more imagination, the less imagination you have, the quicker you'll get the job done. The more imagination you have is actually, in that sense, it works against you, because you think, well, what about this? What about all of these are possible, but most of them are not likely. And probably what you want to do is see, well, what actually happens with this? And that gets you to ask the more meaningful questions, like, well, should we release this API yet? Or should we release it and put a caution on it? It's just like, okay, this is a beta release. We're not planning to support this. This is a beta release. This is for you to try. In other words, it makes us a little more aware. It makes us look up from the keyboard and go, how are people going to use this?
This clip was taken from my podcast, The Engineering Room with Dave Farley, a monthly podcast with some of the brightest minds in software engineering. You can find full episodes on all your favourite podcast platforms, including Spotify, Apple Podcasts and Amazon Music. Your support helps us to bring you these regular episodes, so please leave your positive review on your preferred podcast platform to help us to continue to grow and bring you great guests and their insights. Thank you very much for listening.